Hi, I'm Jeremy Curtis. I'm from the UK Space Agency. Welcome to Tim Talks Space. This is our chance to talk with astronaut Tim Peake about what's exciting in space at the moment. Hi, Tim.
Hello, good to see you.
Where are you? You've got a really interesting background.
Yes, it's a bit different today. I'm actually at the Mars Yard at Stevenage, where the Airbus Centre is. So I'm doing some filming today for a one-show program that's coming up, where we're going to be focusing on the search for life on Mars.
Wow, and is that the real Mars rover I can see in the background?
Yeah, so what you've got in the background there, you might see that moving around a bit. They're driving it around this morning. So this is Bruno. Bruno is a prototype of the Rosalind Franklin rover, which is the real thing. Now that's also here in the clean room. And the Rosalind Franklin will be the rover that actually goes in 2022 to the Red Planet. But Bruno is the test platform where they experiment with all of the sights and sensors and the navigation and controls.
Fantastic. So I think we probably ought to come back and talk about this in a future chat. But for today, we're going to be talking about climate change. However, before we do that, I'd love to know what you think about the exciting events of the weekend with the SpaceX launch. What was your feeling about it all?
What an incredible weekend, and I'm sure many people watching this would have also seen the launch on Saturday. I mean, there's always a huge amount of apprehension with the rocket launch, but particularly for the first flight. And so it was great to see that everything went smoothly. Everything went really well, in fact. And what a spacecraft. I mean, just to see a futuristic modern spacecraft, plenty of room, touchscreen controls, different spacesuits. So that was great to see. And also the docking as well. Great to see that working flawlessly, and good to see Bob and Doug get on board. We're really excited about it in terms of, the UK Space Agency, the European Space Agency, because this is the new transportation system for European astronauts to get to the International Space Station and back. So I wouldn't be surprised if Thomas Pesquet, he's the next European in line to fly. I think he'll probably fly on SpaceX within the next 18 months. It could be Boeing as well, but I would, if I was a betting person, I'd say SpaceX.
Wow, so it's exciting times ahead. Again, we'll probably talk about rockets in a couple of weeks' time, so maybe we can talk a little bit more about it then. In the meantime, we've had some fantastic questions in, and I left you last time with a really good question from James of St Wilfrid's Roman Catholic Primary School, who wanted to know about whether we can measure climate change from space. And we think that's such an important question. We're going to talk all about it this time. Some of his friends from the school have also written a brilliant poem and illustrated it. We haven't got time to read it, but you can look it up on our Facebook page. But in the meantime, to talk about climate change, we really need an expert. So who better than Dr Anna Hogg? She's from Leeds University, and she is from the Centre for Satellite Data in Environmental Science, which sounds very grand. Hi, Anna, what do you study?
Hi, really nice to speak to you all today. So effectively, I'm a glaciologist. I look at ice on Earth, and I go out in the field sometimes to do that, but mainly I use satellite observations. So up in space, even not in person.
That's brilliant. So in space then, Tim, you must have seen some amazing things. Before we start talking about climate change, what was your favourite view from the ISS?
Well, it's interesting that, Anna has obviously spent a lot of time in cold, icy places, and they were some of the most stunning views to see from the International Space Station. I tended to get a bit fixated about Patagonia and the southern ice fields there. They're just so beautiful from space. So I love talking about that. But also lakes and mountains, New Zealand, for example, some of the mountains out near Mongolia as well, absolutely stunning. Volcanoes, seeing the volcanoes in Kamchatka erupting, all of these kind of views, absolutely stunning from space. So what's surprising actually is that some of the places that you think are going to be the most barren and desolate and lifeless places are the ones that are the most exciting. And the Sahara Desert as well. Every time you go to the Sahara, you get the beautiful sort of orange light coming into the space station, reflecting off all of that sand up into the space station. We would always know when we're over the Sahara because of that light coming into the space station. So yeah, these were some of my favorite views.
Wow. And how did you take these pictures?
In fact, there's me in the cupola. It really was a case of just grabbing the camera, going into the cupola, and giving it a go. At first, your photographs don't come out very well. You have to get used to tracking and how to take a good shot from the International Space Station and what lenses to use as well. But ultimately, you get used to that, and it really is a case of just grab the camera when you see something and go take a shot.
Okay, well, let's get talking a bit about climate change then. We've got some great questions, but I'll start with Rosie, who was 10, asking, as climate change progressed, what did you see more and less of? So in other words, has things changed viewed from space? And Molly Ripley, a similar sort of question. What was the most noticeable change of climate on Earth that you could see from the ISS? So that's for you, Tim, I think, first.
So yes, from space, the interesting thing is we don't witness climate change over a long period of time. We're up there for 6 months. But what we've noticed in the 20 years that the astronauts have been on the space station taking photographs is we've been tracking things like glacial retreat. We've been tracking pollution levels over cities. We've been tracking biomass in terms of deforestation of major parts of the Earth. So these are things that we are tracking on the space station over a much longer period of time. What you do see on the space station is you see evidence of signs of pollution, and I'm sure we'll come on to talk about that later as well, in terms of the impact that we've been having on our planet as well. And we see the seasonal change. So I launched in winter, I landed in the summer, so we got to see that entire seasonal change of the planet. But climate change, is something we've been recording over a much longer period than just one 6-month mission.
So you can see a lot from the space station, but I imagine that if you use other satellites, you can see different things. Anna, what else can we see when we use other satellites beside the ISS?
So a really great example is photographs from Landsat of Baltoro Glacier in the Himalayas. So this is a camera, it's a multispectral instrument, and it sees photographs much like the types of photos that Tim was taking. And when we put a long time series of these measurements together, actually you can see this glacier in the middle, and you can see tributaries flowing into it, and it sort of starts to animate. So using the long time series of images, we can see change in glacier area over time, and we can see how these regions actually flow much like river flows in a stream, and glaciers are just doing that, but much more slowly. But we can also make a totally different set of measurements if we use radar satellites. So the next animation is of Thwaites Glacier down in Antarctica in the south. And while this is not a beautiful coloured image, it's taken at a different part of the electromagnetic spectrum, which allows us to see through clouds. So even if there's bad weather, when you're looking up at the sky and you can see clouds, these types of satellites look through all of that in order to be able to see the Earth's surface clearly. Another feature that's really important for this polar glaciology that I study is that it's dark for 6 months of the year in Antarctica and up in the Arctic. And so having these active sensors mean we're not reliant on light from the sun, which again means we can take measurements of the ground surface all year round. So it's great. And you can see all sorts of action happening in this animation. You can see the ice flowing towards the ocean. And you can also see things like icebergs breaking off around the edge of the ice sheet. So lots of activity, even in these really remote parts of Earth, all the time.
And I think we've got a picture somewhere that Tim took from space of an iceberg. Can we get that up? There's a slight delay on the line.
From space, we were able to see just the tip of Antarctica. We couldn't really see Thwaites Glacier. We couldn't see that far down, but we did see evidence of the ice that was breaking up off Antarctica and, of course, flowing up into the Atlantic. And this was one picture I took of an iceberg. In fact, remarkably, I managed to take another photo of this iceberg about a month later, and I was just passing by the window and spotted it in the middle of the ocean and couldn't believe that it was the same one, but it absolutely was. So what is it that you're studying there, Anna? You mentioned two things. Firstly, about the glacier flow. I was really interested about what are you determining from how our glaciers are changing and flowing, and also icebergs. How are you using iceberg data?
So we measure how fast a glacier flows by tracking features like crevasses, for example, on the glacier surface, and we can see them move forward. So we can measure the distance that they've flown into the sea. And when we see a glacier speed up, this means that more ice is being taken from the ice sheet and put into the ocean, causing things like sea level rise, which we all know is a problem. But with regards to glaciers, what we're really interested in doing is, as this example on the screen shows, is tracking cracks as they grow along an ice shelf. So an ice shelf is the ice from the land that's floating on the surface of the ocean. And you can see these cracks propagate along ice shelves over months and years, in fact. Sometimes they can remain intact for decades. But then we want to monitor how fast that crack grows in order to be able to capture the precise moment when an iceberg calves. And then, as you say, with the photo that you took, Tim, we're able to track the location of these icebergs and where they move to. It's often either blown from winds in the atmosphere or dragged along from ocean currents beneath. And so, yeah, we see the glaciers move around the continent. And yeah, it's fascinating to watch it happen in action. And it's sort of something we weren't able to do 5 or 10 years ago. We didn't have the frequency of observations that we now have from satellites. So it's been a total revolution in the types of things we can study using satellite data.
We've got a great question in here from researchers in School Club at Stirling High School. They're talking about the Pine Island Glacier. I think that's in Antarctica, isn't it? Which calved in February. And they're asking whether these events are happening more frequently due to climate change. Anna, do you have a comment on that?
Yeah, so Pine Island Glacier is a really exciting ice stream. It's right next to Thwaites, which you already saw an animation of, so it's its neighbour. And I actually visited Pine Island on fieldwork back in 2014. Over the last sort of 5 years, as this group has noticed, Pine Island Glacier has changed from a glacier that only carved one iceberg maybe once a decade to having carved about 5 or 6 icebergs in really quick succession. And so it's now retreated to its most inland position in terms of its ice shelf. And in fact, that's also been coupled with a recent speed up of the glacier. So interest in this region has definitely increased at the moment. And we want to figure out whether that's due to warming ocean waters or some other physical process that's driving the acceleration and activity on this very large glacier. You saw photos from Tim of these glaciers in the mountains. And the thing that's really difficult is to get a sense of the scale of these features in Antarctica. They are huge. I was out on Pine Island for 3 months and we only drove around on the one glacier for 3 months. It's a very long car journey.
We've got a question from Alice Hutchins, who's 6, asking about how climate change affects people on Earth, the wildlife, the animals and so on. So perhaps, Anna, you can tell us a little bit about how else we monitor climate change. It's not just about ice cover, presumably.
Yeah, absolutely. Changing in the glaciated regions is just one aspect of environmental change on Earth that we try to monitor. We've got some really interesting measurements, for example, of sea surface temperature and sea level rise. So when ice breaks off Antarctica and Greenland, it can cause sea level rise at the coasts in and around the UK. So this is a video of a storm surge in Scarborough, where we can see a weather event combined with higher sea levels due to their constant rise over time meant that coastal flooding can become more of a problem for us here in the UK. If you put the sea surface temperature animation on, I think this is a beautiful picture. You think it's an animation, but it's not. This is real data measured by satellites from up in space. And here we can see the hot sea surface temperatures are represented by orange colours and cooler temperatures shown by blue up in the poles. But it's not just the sea surface temperature we can see in this animation. You can see little eddies and ripples, and these are ocean currents moving around that are affecting the pattern of sea surface temperature. So we can use these data in really interesting ways to examine how change is affecting us all everywhere on Earth.
And what about sea level? Can you measure that from space?
Oh, yes, of course. We can measure sea level rise. And the interesting thing is that we're all kind of familiar with this global sea level rise curve where it's a graph going upwards. But actually, you can see from this animation that it's very spatially variable. Red areas indicate regions of sea level increase and blue areas indicate regions of sea level decrease. And you can see it's not the same over the whole globe. So different parts of the coastline will be affected differently. And that's why it's so important that we have these satellite data available to monitor everywhere all of the time.
And I suppose, there are things that we are all affected by, not just coastal flooding and erosion and so on, but farming and storms and all sorts of things. Tim, there's a question here from Jack Hutchins, who's 8, who wants to know if the space program is doing anything to help our planet. It's a bit of an open question, that, isn't it?
Yeah, well, no, absolutely. And what's fascinating there is listening to Anna and listening to how some of the satellites are helping us gather this data. In fact, over 50% of all of our climate data now comes from space-based assets. So, we need to make decisions here on Earth that are based on hard scientific fact. If we don't know what's happening, then how can we possibly implement a solution, and how can we track the effects of the solutions that we're providing down here on Earth? So space is giving us the ability to monitor our planet like we've never been able to monitor it before, in terms of sea level, in terms of tracking the ice flows, how they're breaking up, the currents you've seen there. And we'll talk about a few other things as well that we're managing to detect from space. So that's really what's vital about the space program right now, is it's actually kind of a finger on the pulse of our planet, so that we can work out what is going on, what are the changes that are happening, and how we can mitigate those changes.
So that's sort of the hard scientific reason for doing all this. What about the emotional level? Did you find that by being in space and looking down on the Earth from above, it changed your feelings about how important all this was?
It most definitely does, yes. Here you're seeing a photograph. This is one of my favorite photographs of space. And all you're looking at there is the atmosphere. Behind me here is the Mars yard. Well, we're going to search for hopefully signs of life on Mars. But if we do find any signs of life, it might be single-celled. It might be very, very basic. But there is nowhere else in the solar system we know of that can sustain life like there is on Earth. And that's thanks to this tiny, tiny strip of gas. And we have to protect that tiny strip of gas. There is evidence elsewhere, of runaway greenhouse gases on Venus, for example, the Martian atmosphere that's hostile. So Earth is it, really. And when you look down from space and you see things like the Amazon, the deforestation that's occurring, or the pollution levels in the Himalayas built up there on the southern side, the Kathmandu Valley is now suffering horrendous pollution levels. And it's really upsetting to see. And you realize the impact that we're having on our planet, and we need to take action. We need to, keep control of this.
So we're going to talk a bit with Anna about what drives climate change. Is that something you'd like to give us a bit more on, Anna?
Yeah, sure. There's many things that can be driving climate change. And one of the things we think affects it is the radiation balance of Earth. So how much sunlight comes in, and then how much of that heat is trapped underneath the atmosphere, and how much is able to escape and go back out to space. And it's that radiation balance that has a really important impact on air temperatures on Earth. And within the UK, we're in a really exciting position to be leading a new future satellite mission called TRUES that will capture and measure this radiation balance with unprecedented accuracy. So this is a mission, I think it's due to be launched hopefully in 2026, which shows you just how long it takes to kind of get the scientific case together, to build the hardware and the instrument, and then to launch it out and have it active in space. And so it's really important for us to be able to measure these types of data sets with real accuracy. I think one of the coolest things I know about this mission is that actually it calibrates itself using the reflection of the moon. And so it's a really interesting example where you're using the moon to kind of improve the accuracy of your satellites. And how cool is that?
And who's actually building it then? It's being built in the UK, you said, but who's building it? Do you know?
Yeah, as all satellite missions are, it's an international collaboration of researchers and industrial teams, but it's being led by the UK. This is something the UK Space Agency has really pushed for to get it onto the agenda. And fortunately, lots of countries agree that this is a really important tool to develop. So I think that there's many different types of satellite missions, but it's not just on board satellites that we can mount these instruments. I think, Tim, you've mentioned an instrument to me that you mounted, or that is mounted on the International Space Station and making measurements.
Yes, we've had several on the board, the International Space Station. This animation you're seeing here is JEDI, which is using laser range finding for looking at the Earth's biomass and deforestation. You know, there's all sorts of sites and sensors we can have. The International Space Station's in a good orbit because it covers so much of the Earth's surface. And so we get to see different parts on every orbit, different parts of the Earth's surface. You know, we use a variety of different sites and sensors, whether they're, you know, visual cameras, for example, or things like this, laser, where you can actually identify very accurately how much biomass there is on Earth. But I was interested on the Truth mission, Anna, as well. In terms of that data, who actually kind of gets the data and how do you use that at the end?
Well, it's a real collection. It's a team effort. You know, science is always a team effort, as I'm sure it is in many fields, where you need to have engineers building the hardware. You need to have researchers and scientists on the ground in universities analysing the data sets. You know, you even need to have lawyers making space law so that the contracts are all in place. And so my background is that, you know, I did geography at university and I've really had a passion for measuring change in the environment on Earth. And so whether you enjoy doing maths, whether you enjoy doing physics at school or geography, you know, there will be a job in space for you. There's a way that you can use your skills and what you're good at to kind of help us expand what we're doing, whether it's with Earth observation data or launching humans into space. And so it's such an exciting field to get involved in.
Would you like to say a little bit, Anna, about what you do in your daily job? I mean, we've heard that you spend some of your time in Antarctica. Have you got a little bit more detail you can give us?
Yeah, so I mean, this is a photo of me down in Antarctica at the British Antarctic Survey base called Rothera on the Antarctic Peninsula. It's a really great place to be because there's so much wildlife around. You can see this giant elephant seal, who I'm not sure if I'm smiling at or looking scared of. They're very, very smelly, so it doesn't look as cute in real life as it does in the photo. But yeah, on day to day, I'm sitting at my desk in my office at university and downloading new satellite data and having a look at these regions that we're most interested in. You've mentioned Pine Island Glacier, and that's an area I'm really interested in looking at the moment. And so it's very exciting to get an image brought in of just a few days ago, and you can see these remote locations almost instantly. But then when you're out in the field, it must be similar to, well, I don't know how similar it is to being an astronaut on the ISS, Tim, but when you're doing field work, it's really remote. You know, you're far away from lots of people, home comforts like showers. I think not having a shower for 3 months was a low point for me. So how about you?
What I find amazing is that actually, I think that people who are in Antarctica are more remote than they are on the space station. I mean, if we really needed to, we could bring back the space station crew within about 12 hours in a case of emergency. That's probably faster than you can get back, especially if you're overwintering in Antarctica. So there are lots of similarities between the crews who go down to Antarctica and what we can learn about living in isolation down there and how we can use that for deep space exploration. So I take my hat off to you, Anna, for those expeditions. It looks like a lot of fun.
Well, it feels like a real privilege to be able to do that type of work. I think we're really lucky to be in such worthwhile jobs that are also so exciting.
I still find it quite interesting that the European Space Agency employ doctors who go to Antarctica just to bring in that experience of working in remote places. I find that quite amazing. We talked a lot about climate change, but the other thing that's on a lot of people's minds at the moment is the current crisis with coronavirus. Some people have been asking whether or not we can see anything from space to show what's happening on Earth as we suffer from this. Can you see the effects, Tim, from the ISS, do you think?
Well, it's interesting, actually, having just said to you before that from space, we're looking at those long-term effects. Actually, I put that question to Drew Morgan, my NASA friend, who's a US Army colleague, and asked him, and he said the biggest change was aircraft contrails, because we see a lot of haze caused by contrails from space, and we see evidence of aircraft flying. And during the lockdown period, that was the one thing that he noticed was a dramatic reduction in the amount of aircraft contrails due to obviously the amount of aircraft that weren't flying.
And Anna, what else can we see from space then? There must be other satellites which can look in different wavelengths or collect different information.
Yes, absolutely. So, you know, the aircraft contrails, they look like sort of long, thin clouds in the sky, and so we can see them with our eyes. But there are other types of measurements, you know, I've talked about that we can measure different parts of the electromagnetic spectrum to measure things you can't see visibly with your eyes. So this animation here shows NO2, or nitrogen dioxide. It's a gas that's given off by burning fuel, so driving cars, driving buses, operating power plants. You can see, using the Sentinel-5P satellite that the European Space Agency launched recently, that the very red areas, which indicate high concentrations of this nitrogen dioxide gas, have decreased massively over the period where lockdowns have been in place and people haven't been going to work or to school. And so, yeah, we can see that the actual composition of the atmosphere has changed during COVID. So it's fantastic that we've got these instruments up in space that can monitor these changes.
That's really good. But I think what we need to make sure people understand is that that's a timeline along the bottom. So you can see as we're moving between December and March, how the map is changing. There's a lot of data on that. So this is one of the challenges I suppose you suffer as a climate scientist, is knowing how to present data in a way that ordinary people like me can understand. But what about the rest of the environment? There must be a whole lot of other things that we're measuring that are not necessarily to do with climate change. And, you know, we talk sometimes about climate and forget that it's very different from weather. So do you want to start with that, Anna, and tell us what's the difference? But what else can we measure from space, either of you?
Yeah, so I mean, things like weather, they change on short time scales. You know, we try and do weather forecasts a week ahead, and you know that rain's going to come in and it's going to move on, and it will be a temporary effect on the environment that we live in. Whereas when we talk about climate change, we're talking about more long-term, more permanent changes that are outside of the normal variability that we would expect due to weather. And so that's the critical difference, really. And as you say, we need to measure those over long time periods so that we can make sure that the natural variability isn't influencing what we think is going on. But there's many other things that we can measure from space. We've seen in a lot of Tim's photos, clouds. You know, measuring clouds is really important for doing our weather forecasting. And there's some great satellite meteorological satellites that make measurements of this on very high frequency time scales. We can measure things like crop health. So if you've got a field and you want to make sure that the vegetation in it is healthy, you can see that using satellite data. So in this image, there's, I think this is a photo that you took, Tim, is it?
Right,
where
yeah.
you can sort of see the different patchwork pattern of crops in different fields in the south coast of England. Is that correct?
That's right, absolutely. Yeah. So this is actually my home turf there, down near Chichester, Portsmouth, Southampton area, and obviously the Isle of Wight. But just, you know, to pick up on a point that you mentioned there, Anna, about the electromagnetic spectrum. One thing I always think is that, you know, we make everything relevant to humans, but we are so limited in our eyes. When you look at the electromagnetic spectrum, that huge range of electromagnetic radiation, and yet all we can see is a tiny, tiny fraction of that in the visible spectrum. And we kind of, you know, it's easy to think if we can't see it, it's not there. Of course, there is so much there that we can't see. And whether you look to the infrared, whether you look to radar or radio waves, I used to use those on helicopters I was flying to be able to see through fog, to see through bad weather, painting a radar picture or using an infrared camera. And now, of course, we're doing the same from space to be able to see these. And we've got evidence from telescopes like Herschel and Planck that use different frequencies as well, different parts of that spectrum. So it's like opening our eyes by using these sights and sensors. We are, you know, opening different sets of eyes across that whole band, and it's amazing what we can see when we open our eyes.
Well, you've just listed a whole lot of things there that will be fruitful for weeks and weeks of discussions on these chats online. Deforestation, pollution, land use, illegal activities such as fishing and dumping oil and pollution and so on. Fires, earthquakes, volcanoes and other natural disasters. There's so much we could talk about, but we're running out of time. So what I think we better do is to give people some suggestions about things they could do at home. Anna, have you got any ideas for things that people could join in to get involved in space at home?
Yes, absolutely. So if you've loved looking at the satellite data today, if you go to the SENSE Earth Observation Centre for Doctoral Training website, we've got an escape room challenge for you to do. So there's a series of questions that will help unlock codes that enable you to escape from the International Space Station back down to Earth. And we'll be releasing the answers to all of those questions throughout this week on Twitter, on the SENSE tweet account. So I hope you enjoy doing that activity.
So that's for younger people, and then for slightly older people, sort of 12 to 18-year-olds, the logo you can see on the left there is the ESA Climate Detectives activity. It's actually based on something that we designed in the UK for Tim, called Earth Observation Detectives, but that's still included in there, so you can go to that. And we've gathered these two resources and a whole lot of other things together in links so that you don't have to try and scribble it down. Go to the UK Space Agency's website, where we've got a page with a whole lot of different activities that you can do at home, including the ones we mentioned last week and the weeks before. So do have a look at those. So that's all we've got time for now, but do join us on the 15th of June, that's 2 weeks today, at the same time, 11:30, where we're going to be talking with Tim. This time we're going to be talking with an expert, Professor Susie Imber, and we're going to be talking about how we use rockets and spacecraft to get to the planets. So do join us then. In the meantime, thanks very much for watching, and thank you, Tim, and thank you, Anna. See you next time.
Thank you, everybody. Thanks, Anna. Thanks, Jeremy.